In our physics lessons today, we are introducing the idea of waves to the students in my school. I'm not sure about anyone else's school, but it's always an 8th grade fun adventure that you can do in the classroom, but current situation kind of puts us in a different situation. So I basically am going to create a video using the waves that I could find in my own house. So the idea of a wave is anything that's resonating or creating a rippling effect with the energy starting from the center and working its way outward. Okay? And then there's two main types of waves. We have our electromagnetic waves and our mechanical waves. Both can be found around your house. And I encourage anyone watching this to look for them and see how many they can find and if they can create their own experiments with the waves. I'm going to walk you through a few, starting with the electromagnetic waves right now. So, the first one, which I don't have an example of because it's in everyone's car, oddly enough, is radio waves, starting at the longest end of the spectrum, as in the lowest frequency. Remember, frequency is how long it takes for one cycle to go in a certain amount of time. Radio waves tend to be the longest. That's why they're able to be broadcasted throughout our nation over many, many miles, and we don't need antennas every few feet or every few hundred feet. One big tower can do the trick if the land's flat enough. The next one I could find in my house very readily is microwaves. Microwaves, they happen to go in your microwave. So anytime you hit the button, turn on the microwave, there are microwave waves coming out of this unit and forced into whatever object is in there. A few of them escape. They're not bad. They're very long, so they're not affecting too much. But so that's the next one. So your microwave is on the wavelength spectrum. Next is infrared waves. And infrared is a fancy way of determining heat and how much energy is being released from this heat. Again, we can turn back to our handy dandy stove again. There we go. So if you ever wondered why a flame tends to have different coloration, the closer to the source, the closer it usually blue or white, the same reading is on the infrared spectrum. In this cone here, you would see a bright white light fading into various oranges and red during the infrared spectrum as the heat dissipates outward. Next on the list is the visible color spectrum, which is basically the entire world around us. Right? Some people do have color blindness, and so they're missing the receptors in their eyes to see certain wavelengths of color. I do not have color blindness. It is more common in males, though. It's a genetic trait. So I can see all the blues, all the greens, all the reds of the world, and so can most of the world, most other humans. Animals see in different wavelengths. Dogs don't see reds. Cats only see a few colors. Most predators tend to have different color spectrums than herbivores. Because if you think about it, if you're an animal eating plants, you need to be able to see which plants are in season. Plants tend to give off color to attract people, various things. And predators just are focused on more of the movement side, which is differentiating the depth of field versus the gray scale and other various kind of grayer colors. Right? The list kind of goes down further from there. I don't really have too many examples of ultraviolet in my house, or definitely don't have any gamma or x-rays in my house, and that's a good thing. They tend to mess with the human DNA and the body a little more than they should. So, from that point, I'm going to jump on to the mechanical side, which our main mechanical waves are water, sound, and seismic energy. This is created by earthquakes. I'm not going to show you any earthquakes. Sorry, I don't have any ability to create earthquakes. Although I do know a lot about them, but I'm not going to make any. So we're going to take a look at the other two, which is sound and water. So over here, this is just a very simple experiment. Anyone can do it. I'm sure many of you have done it on accident and just thought it was fun. But the idea is you can make sound, or you can make water just by dropping in drops into a pool of water. And you can see it resonating outward. The bigger the drop, the bigger the wave, and it's a bigger of an amplitude. Alright? It's pretty simple stuff. So let's go take a look at some more waves. So over here in our fish tank, I have one pump pushing water into this main tank of water, and as you can see, when the water enters in, it breaks up the water tension and the water molecules, creating this wave. So if you look along the side here, you can see the waves hitting, creating the frequencies as it's undulating. And you can see it along there too, the various waves. Alright? It's pretty cool stuff. Next one, sound. Got myself a nice bass amp here from previous times in my life. So musical instruments create sound. We all kind of know that. But the one thing we don't realize is the sound is created by the vibrations of either a reed, a buzzing in your lip from a mouthpiece, or strings on string instruments. In my guitar here, I have 4 strings, and each of them is related to a note, and that note is related to a frequency. So if I pluck one of these strings, I'm going to hear a specific frequency. So this is the E string, and it creates this frequency, and it resonates. And you can hear it as it drifts outward through this amp, and a little bit through the actual string. Each string represents a new frequency, and I can augment it by pressing down on the frets. So musical instruments are just altering frequencies to create sound. And now, if I was to turn up the volume, that would be changing the amplitude, the height of the wave. So the higher the volume is, the bigger the amplitude. While the lower the volume, the smaller the amplitude, or the height of this wave. Alright? So there is one cool thing that we can do using water and an instrument, is you can place a little bit of water on an amp or speaker, and you gotta be careful. You don't want to ever ruin your equipment. There's electricity involved. You don't want to shock yourself or hurt you or the instruments. So if I was to play this, there's little vibrations coming out. There's not enough because the water is dense enough. Now if I place my arm on the actual box, I'm picking up, my body is now picking up the vibrations of the energy, and I can transfer it into anything I want. So if I play the string and transfer it, you can actually see the water start to vibrate because I'm adding another layer of energy to it. Pretty cool, huh? Alright, thank you for watching. Hope you learned a little bit about waves.